Welcome to the first tutorial on PROSv Basics, how to program in PROS if you've never programmed before. I'm understanding that a lot of the juniors in the academy don't really know how to program very well and are trying to program using block code. And while that's completely okay if you know what you're doing, it can be a little bit challenging at first, especially when you're trying to transition from block code to PROS or to try and do more complex things within block code. So that's why you might want to consider learning PROS, where if you need help, Dr. Chugani or myself or Arian will be able to give you the help that you need, as well as just understand your code better. As well as PROS in the future will help you if you intend to go into a career that is going to involve programming. So the first thing you're going to want to do when you start programming in PROS is, of course, to download PROS. You can download PROS by going into the link in the video description or by searching up PROSv5, and then most likely the first link that you're going to find is going to be this one right here. You just want to scroll down on this website and we can see a download here, and then you're going to want to click Getting Started. This is going to take you to the PROS documentation. You're probably going to want to bookmark this website or at least remember how to get to it, because this is the most useful place and you're going to be coming here very frequently. First thing we want to do, however, is go ahead and click on Installing on Windows. And then we can download the exe file by clicking right here. Scroll down, and if you are on Windows, you're going to want to go ahead and grab either this exe version right here or the MSI version right here. It really doesn't matter which one. If you're on macOS, you can also use PROS on macOS. However, it is significantly difficult to install, and I would recommend Googling up how to install either a Windows virtual machine or how to dual boot your Mac with Windows on it. Or, if you choose, you can also do it with Linux, as installing PROS on Linux is as simple as running this one command right here. I've done it before, it works quite well, and it's actually easier to install on Linux than it is on Windows. So yeah, go ahead, grab an installer, and install it on your system of choice. Now, I'm going to assume at this point in the video now that you've already done that and you've already opened up the PROS editor. The first page you're going to get to is going to look something like this. And hopefully you won't see this right here. I do. It doesn't really mean much, and you can still do everything you would normally do and stuff. To create your first project, you're going to want to go up to the top menu bar here and click on PROS. You're then want to click New Project, and it's going to pop open with this little window right here. In this thing, text box right here, you can select where you want your project to be. Oops, don't want to do that quite yet. And if you click this little icon right here, it's going to open up a file explorer, and you can just select wherever you want to put this. So personally, I'm going to put this in my documents and GitHub and 1010v repo folder, as this is going to be able to sync it to my GitHub. Everything we're going to do here today is going to be available on my GitHub repository, and I'll leave a link to that in the video description as well. I'm going to select folder, and then you can see it's automatically going to open it up to this project directory right here. I'm going to add another slash right here, and then we're going to title this project Learning Code 1. And then we can also click down on Advanced here, and you can see we've done our project. It's already filled our project name in with Learning Code 1. And then if you so choose, you can choose to not install default libraries, or you can choose an older kernel version. However, I would recommend just leaving this advanced menu untouched for the most part, unless they release a new kernel and you find out that it no longer works or has some sort of bug, which can happen from time to time. Then you can just go back and you can select the last kernel instead of the latest one. Otherwise, you don't really need to touch anything in the advanced menu. Go ahead and click continue, and you're going to see this little window up here. It's going to download the new kernel and create our new project. Boom. Once it's done, you're going to see this, and you're going to see it's going to build your project for the first time to make sure that everything is good and okay. If this doesn't go through, you have a problem, and you should probably try and reinstall Pros. Sometimes you might also get another message here in red saying Pros CLI not found on path. If you get that message, you can try reinstalling Pros. If you get that message a second time, you're going to want to Google around a little bit and see if you can find a solution. If not, you can go and contact RA&RI, and we can probably help you out with that. One other thing is there should also be a fix for that on my GitHub here. I don't know if it's still here. Here it is. If you go into the Pros CLI folder right here on my GitHub, you can copy and paste all of this in to the Pros installation folder, wherever you installed Pros 2 previously, and use it to replace what is pre-existing in there, and that should fix the problem. However, if you don't really know what you're doing, that could also make it worse. So if you don't explicitly know what you're doing, maybe just ask RA&RI for some help with that before you go ahead and do it. Dr. Chugani should also be able to help you with that. I just don't know if he's ever done that before. Alright, so before we open our project, we can just go ahead and close all of these random windows here because they're completely unnecessary. Then what we're going to want to do is we're going to go ahead and open up our src and include folders. There are two main files that we're going to need to pay attention to at first, and that is our main.h file, which should look like this before we do anything, and our main.cpp file, which is going to look like this. Now, included in this file by default is some documentation, as well as a few basic functions. The first one is this right here. Essentially, this is a nice little program that they've included that when you press their center button on the LCD screen, it's just going to print on the LCD I was pressed. It's not useful at all, really, and if you want, you can go ahead and delete it. But if you do, go ahead and also delete this line right here. So we're just going to go ahead and do that now because it is kind of useless. Yeah. Okay. And then Control S to save when you're done. Always save. If something crashes and you lose your work, that would not be super ideal. So for now, we don't really have to pay attention to a lot of this. Especially the documentation. So if you hover next to this right here, there will be a little arrow. You can click that and it will just minimize the documentation without deleting it, which can be quite useful. So I understand that you have a tournament coming up this weekend, at least at the time I'm making this video. So we will dive into how to make an autonomous using Okapi in the next video. However, for now, we're going to finish on getting a basic operator control up and working. So the first thing that's going to entail is defining all of our motors and sensors if we have any. And to do that, we're going to need to start in our main.h file. So we can go into our main.h file, and then basically anywhere in this file in between these lines here and these lines here, we can put anything. However, typically I like to put it right around this middle space right here. So in our main.h file, we're going to want to define the names of all of our motors. And because this is a .h file, we're not actually going to define anything in it. We're just going to say that, hey, this is defined somewhere in the program. And basically, the reason why we're doing this inside of our .h file is because so that in the future, when we introduce other files into our program, they will also be able to get those references and use them. And essentially the main reason we want to add more files into our program is we're going to do that when we create our autonomous, because our autonomous file, we're going to have a lot of autonomouses, and it can get quite lengthy quite quickly, and just generally that length and that messiness, it tends to make our main.h file really messy. You can see it's only 74 lines right now. But once you get all of your op control in here and your autonomous and all of your initialization code, it can be a few hundred lines. And it's a lot easier to just go to your autonomous file than it is to scroll through your main.h and find out wherever you put your autonomouses within your main.h. In previous versions of Pros, they had everything split up into autonomous and initialize and operator control instead of just main.cpp. However, they combined it into main.cpp, and I'm not sure of the exact reason, but I think it was to save on space or something like that. Alright, so now defining motors. So the first thing we're going to want to type before we define anything is the word extern. And essentially this is going to allow our program to know that this is defined somewhere else. If you forget to write extern, essentially what will happen is right now, because we only have one file, it won't cause any issues. However, if we start to include our main.h into other files, as we will in the future, it will cause issues, because if we're defining something inside of a .h file, it's basically going to run the .h file inside of every CPP file, and it's going to define, if we forget to put extern, it's going to define the thing inside of every .cpp file, and it's going to make the code start freaking out, basically. So to define, we're going to go extern, and then we're going to type in the word pros, and then we're going to use 2 colons. And then whatever we want to define. So first of all, we're going to start with motors. So capital M, motor, and then type the name of the motor. So personally, I like to use the initializations like drive RB for drive right back. However, you can use anything you want. You could make this drive motor right back. You can make this RB drive. As long as it's a name that is simple and you're going to remember, because especially something like your drive motors, you're going to end up typing these a lot. So if you make it like drive motor 5 right back 12, it's going to get really repetitive typing that out, and it's going to take you a really, really long time. So try to keep it to something simple like drive RB. So we're just going to keep going here. With all of our definitions, we can go drive left back now, and then after every single line we're going to want to put a semicolon, and some languages like Python don't put anything at the end of a line. However, C++ puts a semicolon at the end of every line to essentially tell the program it's time to move on to the next line now, and that's just how the compiler works. If you forget to put a semicolon, you will get an error, so it's just, and you won't be able to compile, so it's just also something to be aware of. And then I go ahead and put RF for right front. Capitalization is a big thing here. I normally use my other keyboard, so yeah. So personally, I'm using 4 drive motors on my robot, so I'm gonna define 4 drive motors. However, if you had 8, you could, or sorry, if you had 6 drive motors, you could define more drive motors. Just drive center left. Oops, for an S there. just like that. However, my motor, we have a Mogo design, so we have 2 intake motors, and then we have a motor that we're using for our like cap lifter thing. Sorry, I don't know how to quite describe it. So I'm gonna call these. So I'm gonna call these conveyor and intake and let's call this tower motor. Alright, and you notice my robot has a spare motor on it right now. We could just put another motor on here and call it test motor. Or how about we go ahead and call this arm motor. Or I understand a lot of you are building tower bots, and you have 2 motors, so we can just call this tower motor 2 for the sake of this, or we'll just call this tower motor left and right for the sake of this tutorial. And then the last thing we're going to want to do, while we're inside this file is we're also going to define a limit switch. So if you don't know what a limit switch is, you're going to want to go ask Dr. Chugani. Dr. Chugani, what is a limit switch sensor? Because that is a very useful thing to know. Essentially, a limit switch is like a button, except it has a little thing poking off of it and is super useful because you can put it anywhere on your robot where a mechanism is going to hit it, and essentially it basically tells the program, hey, you can't move the motor past this point. And I'm going to tell you how to program that in. And it is super useful because if you have an arm, for example, that cannot be lowered or raised past a certain point, you can put limit switches in so that the motor simply won't try and move it past that point. And that'll be super useful to keep your motor cool and keep it from stressing out and your driver just trying to make it go higher and your motor not physically being able to do it but still trying. Basically, adding a limit switch will eliminate that. And to define a limit switch, they're defined in PROSv as PROSv ADI digital in, and then the name of what we want to do. And for this, I'm gonna call it tower limit lower. And PROSv digital in tower limit upper. You can tell like various naming schemes here. This is all lowercase, this is lowercase and a few uppercase. I can put underscores. You don't think you can put dashes. I think you can use numbers, but don't take me on that because I've never actually done it before. I'm not quite sure. Yeah. This right here is essentially, if you hate typing out pros before every single motor, you can just define this using namespace pros. However, we're not going to do that right now because we're going to be using the Okapi library to do our autos because it's the easiest way to start our autos. So just for now, we're going to use the pros prefix instead of using namespace pros, as well as using the prefix is just generally considered the proper way to do things. So yeah. All right. But that's basically everything for now inside of our main.h. We're now going to want to go over to our main.cpp. Oh, and this is a really cool feature. If you want to look at 2 files at once, you can simply grab it from up top here and move it to the side here, and boom, we're now looking at 2 files at once. Great. sorry, I forgot one last thing that we're going to want to do inside of our main.h is we're going to extern our pros. Whoops, I forgot a capital controller, and then we're going to call our controller master. However, you could call your controller controller if you really wanted to. The reason why I call it master is basically my seniors. When I was a junior, my seniors called their controller master, and I just got really used to calling it that. So we're gonna call it master. However, if you want in your own code, your own code, you can call it controller or drive stick or input thingy, literally any name you want. This is your code. You can do it however you like, so long as it follows the basic rules of C++. And the reason why I also call it master is because if we wanted to ever do a partner controller, basically we would define a second controller here as partner. Boom. But again, these names can be whatever you want. The other thing is pros in its official documentation does use master and partner for a lot of their stuff, so just be cautious of that. Yeah. Alright, so the first thing we're going to want to do now is we're going to want to make sure that main.h is included inside of our main.cpp file. As we're pretty much done with main.h, I don't think I have any more things we forgot about. Nope, we should be good. And we're going to want to move over to our main.cpp file. This is where it's going to start to get interesting. So just like before, we're going to want to start over here with our motors. Typing out the same thing, pros, motor. You notice this time we didn't use, oops, I'm just going to put this above here. You'll notice that this time we chose not to use the extern, and that is because we're inside of a .cpp file. We don't use extern. But this basically follows the same scheming as before. We're just gonna go drive RB, and then inside of here, we're gonna want to enter in a few things. So the first number we're gonna enter in is our port. The second thing we're going to want to enter in, we can go ahead and type e_motor, pros, e_motor _ gear set, and then you can see three things pop up here, 6, 18, and 36. And you can see under all of them, they have this little piece of documentation right here. Oh, you can't really see my mouse. There's a little piece of documentation on the very bottom here. You can see it changes when we move up and down. We can see that gear set 36 is for red motors, gear set 18 is for green motors, and gear set 6 is for blue motors. So if your motor is blue, green, or red, you're gonna tell the, basically in this part, you're gonna tell the program whether it's blue, red, or green or whatever. So for our drive-based, we're using green motors, so we're going to use motor _ gear set 18. The next thing we're going to go ahead and do is set whether the motor is reversed or not. So basically, all of the motors have the spinny arrow on the side of them. If you want it to keep spinning in the direction of if you want the positive direction to keep being the direction of the arrow, we can set this to false. However, if you want it to be opposite, spinning, however, let's say you position the motor in such a way that you want the positive direction to be opposite that, you can set this to true. So for our right drive motors, we actually do set this to true. And then lastly, we're just going to do pros e_motor _ encoder and set this to degrees. You don't explicitly have to do this last one. It is recommended though, as it makes your motor a little bit more accurate. for things in the future, but it doesn't particularly matter at this point because we're not doing things that complicated yet. Go ahead and basically we're just going to copy and paste this a bunch of times for all of our motors. Because, hey, guess what? They're all the same, except we're going to want to change this to drive RF because they're not all called the same. And then we want this one to be the left back motor and this one to be the left front motor. And then we can change this motor to be our tower motor. This one can be tower motor L. I accidentally forgot an R there. Oops. And then here we can change this to our conveyor. And this to our intake. Just like we defined right here. And then for our left drive motors, we don't want them to be reversed. However, we do, and then our left arm. The one thing we're going to want to be cognizant of is if you have two motors on an arm, you're going to want to make sure that at least one of them is reversed, so that when you enter positive into both of them, they're both spinning like this. They're both gonna move up like this, because naturally they're gonna want to go like this, but you want to make them synchronized. Yeah. We can just set these to false right now. Boom. And then the last thing we're going to want to change is our ports. For now, I'm just going to set these like 1, 2, 3, 4, 5, 6, 7, and 8 to make life easier. But when you actually build your robot, you're going to want to change those up to the actual ports you have those motors on. So, yeah. All right. First thing we're going to want to do now that we're in our main.cpp file is go ahead into initialize and basically delete this code because it's useless. Now, instead of void initialize, we're going to want to make sure that we have tab. We're going to want to make sure that we have a tab outwards here. And then here is where, so all of our motors are now initialized. So our program knows like what they are and stuff. Oh, sorry. We're also going to need to, in here, do our limit switches. Hooray! ADI digital in. Boop, boop, boop. Let's just move this over here so that we can see it. And this is why it can sometimes be useful to have two files open so that we can see them side to side. We're remembering also to put a semicolon after the end of each line. Tower limit lower. And then here, same thing, brackets. And then we're going to want to put in a port. So for our ADI ports, if you don't know what ADI ports are, they're the little 3-wire ports on the side of the V5 brain. They're labeled A to H. Now, PROSv5 actually accepts two ways of doing this. First of all, is like this, and with capital letters. So we can do A, H, B, C, D, E, whatever. The other way we can do it is, say we wanted to do B. B would also be number 2. A would be 1. Like, yeah, guys, it's a pretty simple naming scheming. Tower limit. Yeah. So for the purpose, I think you can also do this with lowercase letters, if I'm not mistaken. It should work. Yeah, so you can see even in the documentation. Yep, so we can see that, yeah, if you hover over basically anything in Pros, a little pop-up will appear that basically gives you information on it, and it is super useful. And even as someone that's been doing this for years, I still read it because it can still give you useful information, like this. Like this past year, or when I started programming again this year, I was like, what is gear set 18? Oh, it's to tell the program that this motor uses green gearboxes in the motor. Easy. Okay. So the next thing we're going to want to do is go into void initialize, and we have the option here of setting motor brake modes. This is not the same thing as a PID, and I want to be very, very clear about that. A PID is going to actively look to see if the motor has moved away from the position it wants it to be at, and then it is going to move it back to the position where it wants it to be at. A brake mode is literally just that. It is going to make your motors really difficult to spin when they're turned on. So there's a few different brake modes. There's coast, brake, and hold. In my opinion, or at least in my experience, hold is utterly useless. Typically, I only use this brake mode thing for e_motor_brake and for my drive base. So if you're going to want to quickly type that out to match this code, you can, although it's not strictly necessary. Although not strictly necessary, I would highly recommend it, as it defaults to coast, which basically means that your motor is kind of just going to naturally like slow down and stop moving due to friction. And then if you try and spin it by hand, it'll move pretty easily. And if you try and move it by hand, also means if another robot tries to move it by force. So it is useful to do e_motor_brake because, and yes, I know it has brake here twice. That's just the way it works. And I actually just realized that. I've never noticed that before. But yeah, this is a super useful thing to have on your drive base because it makes it more accurate, which is something we'll get into later when we look at autos, but it also prevents your robot being pushed around a lot on the field during operator control. Will this completely stop the issue of your robot being pushed around on the field during operator control? No, not even close. But it will make it significantly harder for your opponents to do that. Right. Now, for the purpose of this lesson, we're going to skip right ahead to operator control. And the first thing we're going to do is delete everything that's here so that it looks basically like this. Then we're just going to take this line that they've put right here and Control X, and we're gonna move it. I like to usually put our controller definitions right at the top of the page here. If you have a partner controller, we can also add another line here and change this to whatever we call our partner controller, and then change this to partner instead of master. And boom, we now have two controllers, master and partner. All right, now I'm not explicitly going to teach you how to write a whole operator control. I'm simply going to teach you how to use if statements, how to use controllers, and how to spin motors. So the first thing we're going to want to do is we're going to want to make sure that we left our while true loop with our 20 millisecond delay intact. Please don't change the 20 millisecond delay to less. It won't help you. It's not one of those things where it's like, hey, eliminate the delay, faster response time. No. The delay is specifically set to 20 milliseconds because I'm like 85% sure that 20 milliseconds is the rate at which motors can update their speed. So having this at 20 milliseconds actually increases efficiency. And it actually probably it decreases latency and holdups. I mean, the amount that it would do that would be like so small that it would be so insignificant, but it could. It's like a possibility. I personally just leave it at 20 milliseconds because it will hurt you to move it higher, but it won't really do anything besides starve your brain of resources. And the PROSv5 documentation actually has some reasoning on why they set it to 20 milliseconds, because it actually used to be 15 as well. All right, moving on to writing our operator control. First thing we're going to want to do is initialize two variables. So there's actually two ways that we can do driver control. There's tank drive, which is essentially the right joystick is going to move the right side of the robot, the left joystick is going to move the left side of the robot. However, please don't drive like that. It's stupid. Just no. So what I'm going to be teaching you how to do is basic arcade control. And how we do basic arcade control is we're going to first want to initialize our two variables. We're just going to call them X and Y, but you can call them whatever. It doesn't matter. It's your code. You can choose. And how we're going to start by initializing these variables is these are number variables. So we're going to start by initializing them with the word int or int or initialize. And then the name of the variable. And then we're going to set it equal to. And then we're going to type the name of our controller. So for me, that is master. Dot get underscore analog. And then you're going to see if we click tab, it's going to do this funny little thing where it finishes the thing, and it also implements this text and gives us nice little brackets and everything. And then the first thing we're going to do is pros, just like normal. E underscore controller underscore. You're going to see there's a bunch of them in here. We're just going to go ahead and type analog, and it's going to give us four options: left X, left Y, right X, right Y. And we're going to want to use, first of all, left Y. Oops. For our Y variable. And then again, int X equals master dot get underscore analog pros E underscore underscore analog underscore right X, and making sure to put a semicolon after every single line. If you have Mecanum drive, you're going to want to do a third line right here. Int Z equals master dot get underscore analog, because and essentially get analog is we want to get an analog input, so our controller has 4 analog inputs, X and Y on, so 2 analog inputs per each joystick, and there's 2 joysticks, so each joystick can do X and Y, and it's basically there's the left joystick Y variable and right joystick X variable, and then we can also go E underscore so then for our Expo drive, we typically use left Y. left X, if you wanted to do mecanum drive. Then we're going to get into motors. So there's two ways that you primarily use motors. And you always start, just like controllers, with the name of the motors. So we're going to start our first one with drive LB. And the first thing we're going to do is type in move, and you can see already it's popped up with a bunch of autofilled suggestions for move. There are two main ways that you can move a motor in pros. There's move voltage and move velocity. And then you can also just type move, and it defaults to move voltage. For our drive base, we're just going to be using move. But let's say you wanted to set a motor to spin a specific RPM. You could also get it to move velocity, and then you can input 100, 200, 400, 600, like however many RPMs you want the motor to spin at, and it'll try its best to do that. However, for drive base, we're just going to do, we're just going to use move. All right, and then we're going to type out, and then for drive, sorry, I just stole that from my other code. So essentially, for the left back motor, it's going to be X plus Y minus Z. If you have mecanums. If you don't have mecanums, don't worry about the Z at all, and just go X plus Y. And then you just want to grab your other four motors and type out the same thing. I'm just going to copy and paste because this is quite a repetitive process. Oops. Yeah, and then essentially you can also see when I copy and pasted it in there that I also have Z values. So these middle two are, if we wanted to include Z, would be plus Z, like that. And then these other two here would be minus Z, like that. And that will allow us to do mecanum drive. However, since on our robot we're not doing mecanum drive, we're just going to leave it as X plus Y for now. And there you go. At that point, you've set up basic drive code. The only thing left to do is to get our conveyor motors and our intakes and our towers running. However, that is super simple. First thing we're going to go ahead and do is create an if statement. So if, and then we're going to want to type in our controller. This time we're going to use get digital. And then inside of here, because we want to grab a digital input or a button from our controller. And then, just like last time, pros, e underscore controller underscore digital this time. And then you can use whatever button you want here. A, Y, X, B, you can use the left or right triggers. You can use the arrows are defined as left, right, up, down. However, we're going to use L1, and we're just going to do an example with our tower motor. Alright, then we're going to want to use these squiggly brackets and click enter, and there's our if statement. Well, at least the beginning of it. So we're going, if you've ever done block coding before, you basically know how this works. If you've never done block coding before, simple explanation is an if statement is going to look to the condition. So essentially right now that condition is master.getDigital equal and master.getDigital, and the digital that it's going to get is the left one trigger, and it's going to see if that condition is true or not. And for a button, the condition is true when the button is pressed. And if that condition is true, it's going to run the code that is inside of these brackets right here. So the code that we're going to put in there is we're going to want to move our towers. Tower motor L, and then we can say move underscore. This time we're going to use velocity. This time we're going to use velocity, and because it's a 200, and if you have 200 RPM motors on your arm, like you'd have a maximum value for this of 200. However, we're actually going to go ahead and change this to 36, just so that we have red motors here. And then that means we're going to want to spin this to a maximum RPM of 100. Because that's the maximum RPM that a red motor can spin. However, if this was a green motor, we could change that to 200. And then we're going to want to copy and paste it again, making sure we're putting semicolons after the end of each line, and change the R to an L so that both of our tower motors are now spinning. However, if you've ever done block coding before, you'll notice a fatal flaw with this plan. Essentially, what we're doing right now is we're going to look and check if our condition is true, if our left one button is being pressed, and if it is, we're going to go ahead and we're going to run those motors at their maximum speed. However, it's not going to stop them. And we're also not going to be able to move them in the other direction. So, simplest way to do this is to copy and paste the whole thing, the whole if statement so far, and just paste it below. And then, to make this a continuous statement, we're going to want to add an else to the front of the second one. And the reason why we're going to want to do that is because we're going to want to make, we're basically going to want to make an if-else statement. And the reason why we do an if-else statement is so that we're not sending conflicting instructions. The other thing is we're going to want to change this L1 to L2, and then change this 100 RPMs to negative 100 RPMs. But essentially the reason why we're using an if-else statement with the else if in it instead of just a bunch of random if statements is two reasons. First of all, it makes it easier to have an else loop, or essentially something that is going to run when we don't have any of these conditions being true, when we're not pressing any buttons. And essentially when we're not pressing any buttons, we want the motors to not spin. So we can get rid of this whole statement here and then simply write else. And boom, this right here is our full, this right here is going to be our full if-else statement. And this right here is our full if-else statement. It's pretty awesome. And essentially what this is going to do is if we're pressing our L1 button, it's going to rotate the motors in a positive direction. We're up. If we're pressing our L2 button, it's going to rotate the motors down. If we're not pressing any of the buttons, it's not going to rotate the motors. However, if we press both of these two buttons at the same time, instead of the motors shaking, trying to go up and down at the same time, they're just going to go up. Because our if statement takes priority over our else if statement. And that's one of the other reasons why we use an if, else instead of just a bunch of else's. The other thing you can do is put a semicolon at the end of your else statement. Don't ever put a semicolon right here. If you put a semicolon right here, it will break your code. Don't do that. Because a semicolon is defined to tell the program when to move on. And this is all one thing. So if we tell it to move on right here, it separates this from the rest of it. And it doesn't know what to and basically it expects that there's going to be an if before an else if here. So yeah, at this point, you should now have simple drive code. We've basically been through everything. I know it's been 50 minutes. It's been a really long time, but thank you for watching this. I hope you've learned a decent amount, and next time I'm going to go over how to set up multiple files and how to quickly get Occupy running with autonomouses. But for now, you should have learned the things we learned today were how to define motors, how to set brake modes on motors, how to get controller inputs, and how to make our drive base move, as well as how to write a simple if else statement using controllers and making our motors move. So if you are to run this code on your own robot now, you should be able to drive around. And congratulations on programming your first robot or graduating from block code to an actual programming language. I'm very happy for you. Once again, all of this code is on the GitHub here. I'll upload it right now before I forget. It's all going to be under the main 1010v repo right here. You can find it right here. I can quickly do it well on the video even. If we push this to GitHub, oh, looks like we won't be able to. This is going to take a little while. Anyways, it will show up right here. Oh, there we go. We can refresh this page, and boom. We can see learning code 1 is right here. You can go ahead and click on this, click on SRC, and all of the code is right here, and you can take a look at it. Once again, thank you, and I look forward to seeing your robots compete at a higher level.